Let's take a look at this then. So very important that you read every piece of information when it comes to a free response question. Do not skip down to the question. All right, I really recommend against doing that. Read through everything here. All right, so it says the rate at which people enter an amusement park on a given day is modeled by the function E of t. So E of t, you can kind of get that. And again, E probably stands for entering, right, or entrance. Okay, so they don't just pick random letters. Oftentimes there's kind of just to help you remember it. So this is the rate of entering. Okay, and the rate at which people leave the park on the same day is modeled by the function L of t. So again, L for leaving, so rate of leaving. And you may write on your free response questions too, okay? You will not be graded on anything that is not written in the answer boxes. Okay, so there'll be boxes for you guys to answer in below, the little question-y things. So you write all over up here if you want, but all your work needs to be in the little box. So this is just for our clarification. All right, both E of t and L of t are measured in people per hour. Okay, so that's good. There's a unit right there, people per hour. And t is in hours after midnight. Okay, so our starting time is midnight. Okay, these functions are valid for 9 less than or equal to t less than or equal to 23. Okay, so we only use these functions for these intervals. Okay, the hours in which the park is open. So that means the park is open from 9 a.m. to 11 p.m. Okay, on the same day. Right. Okay, because that's 9 hours after midnight is 9 a.m. 23 hours after midnight is 11 p.m. Right. So at t equals 9, there are no people in the park. Okay, no customers. We'll say this is really customers entering, customers leaving. Okay. So letter A. How many people have entered the park by 5 p.m.? Which they already give us here, converted, is time t equals 17, right? 5 p.m. is 17 hours after 24, yeah.
So entrance does not imply they stay?
Right. It does not say how many people are currently in the park.
Yeah.
It says how many people have entered the park. So people could have left, people could still be in, that's fine. So we want to find how many people have entered the park. What's our setup here?
E of 17.
So E of 17 is not E of 17. Connor, do you have a question or comment?
Well, I was going to say, why don't we do T equals 8? T equals 17.
Because 5 p.m., so 5 p.m. is it's time at time T equals 17, because 5 p.m. is 17 hours after midnight.
Yeah, but it's the
great.
thing is only valid.
Say again?
The equations are only valid
from 9 to 23, right?
So when 9 is the starting point?
Yes, 9 is our starting point here. That's right. So E is not.
E is the rate.
Yeah. So okay. Let's just hold off here. So again, E, okay, is our rate of people entering, but I'm not trying to find the rate at which people are entering. I want to know how many people are in the park. So what do we do here, Brandon?
You find the definite integral
Yeah,
between
integrate.
Between 9 and 17 of E of t.
Yes, exactly right. Okay, and you may use, if you want to, without having to, if you want to save yourself some time, because this function, this thing is already referred to as E of t, you may just write this out. You don't have to actually write out the function. You may just use E of t, because it's already been defined. E of t is that thing. Okay, that's the setup. Are we all okay with this? This is like that net change stuff we were doing yesterday. Okay, from time t equals 9 to time t equals 17, which is 9 a.m. to 5 p.m. Okay, we integrate that rate, we get the total amount of people. That'll, or not total.
0 to 8. Because, just because it says the same as
okay, but again, you have to think about here, time t is hours after midnight. So when you integrate from 0 to 8, that's from midnight to 8 a.m. The park's not even open yet. These are not valid until 9 to 23. You see the difference there? Yes, it's 8 hours, but it matters which 8 hours you're talking about.
Yeah.
0 to 8 is not the same thing as, in our case, 9 to 17. So we want 9 to 17. And so that's what we're going to do. That's it. That's the setup. That's all you got to do. So now we're going to go to our calculators. We have to show our setup, and then we're just going to do it with our calculator. All right, I'm going to type this into my Y1 here, so because I can see there's going to be 2 of these things, so chances are I'm going to be typing this one in too. All right, actually, no. Okay. Right, this is wrong. Good job. It's wrong. What did I forget to do here?
Parentheses.
Parentheses are on the denominator. Remember that, Emma? That was way back in the day. You do? Yeah. Like, that Mr. Whitmire's a jerk. Yeah, I think before, because I was like, you guys got this, right? And I feel like it was like you were like, yep, I got it, or whatever. And I was like, no, Emma, you got to put parentheses around the denominator, or something like that. I don't remember. Maybe you forget, so it doesn't even matter now. It's okay. All right. So there's our function, and we're going to integrate that. So math 9, vars, y vars function y1, comma x, comma 9, comma 17. And we do some more. 6004.270324, but it says round your answer to the nearest whole number. So what are we going to say? 6,004 people. Okay? Good. And we're going to use correct units too. It's an amusement park. Say again? Well, so is that what this means though? Because we integrated the rate, it's going to be actually just a number of people. Okay? If though, and if I just like plugged like 17 in here, if I plugged 17, if I did E of 17, that value would then give me the rate of change. That would be people per hour at time t equals 17. That would be telling me that. But yeah, right now we're just so 6,004 people. Okay? Have entered the park.
True.
All right, let's take a look at letter B then. All right, the price of admission to the park is $15 until 5 p.m. Then after 5 p.m., the price of admission to the park is $11. So how many dollars are collected from admissions to the park on this given day where we have these rates here? Okay. So we have two different admissions that we charge depending on what time of day it is. So how can we like model that here using the integrals? What should we do? Yeah, Ryan?
Alright, so basically you do 15 outside of the integral.
Okay, so 15 for the dollars,
Yeah.
okay, times what?
The integral from 9 to 17.
Okay, so from 9 to 17, right, that's at $15, until 5 p.m. So from when it opens, 9 to 5 p.m., which is time t equals 17, it's $15. Okay, good. And we're going to integrate what? Bless you.
E to t.
E of t. dt.
Plus
Plus
11 times the integral from 17 till it closes, so 23.
Bless you. Yep, 23. So yeah. So we integrate from 9 to 17 for the $15 price, plus then $11 price from 17 to 23, and again that's E of t still. Notice this L of t, by the way, we have not used this L of t at all. It has not shown up or anything, and that is again not atypical, right? It is typical for free response questions. Sometimes you'll be given a piece of information, and you won't sometimes use this piece of information until like a later question. So just hold off on that right now. We're still focused on just the people entering the park. Okay. So again, what you can do here, well, we already know from 9 to 17 what that value is, don't we? What is it?
6,004.
So we can do just 15 times 6,004 plus, and then we have to figure out this integral. Okay, so all we have to do is just recall that previous command that we did and go from 17 to 23 instead of 9 to 17. And I get this. So we'll do 11 times 1,271.
Yeah.
All right. And actually, we're done here. I don't need to continue this. I can just circle this answer, and I can just say dollars. Yep.
For like a problem like this, if you were to actually find the answer, which I did,
Mm-hmm.
and you put the dollar sign.
Dollar sign's fine.
That's fine.
Dollar sign's fine. Yep. Dollar sign's fine. But you can also put the word dollars there and then just circle the answer, and that's fine too. All right.
What was the answer?
It's $104,048.
Doll hairs.
You can't have cents because you're multiplying halves of people.
Right. Yeah. You should round to the nearest whole number is what it said in this answer too. Round to the nearest whole
I
number.
just wanted to give you a
Oh, okay.
We have great rates.
Someone asked
Only
for
some halfway
we
into the
thought about
park.
80% of their biggest value video.
All right. So there's that one. We're good on that. So far, so good.
This is where it gets fun, right?
Well, we'll see here. So let's see what the next thing says. All right, so next thing. And again, by the way, folks, here, like, this setup is important, right? You could potentially be getting points out of this if you, like, set it up correctly. All right, if you wrote the actual function E of t, that's okay. Again, but again, since it's already referred to as E of t, it's fine to leave it like that. All right, letter C. Let h of t, capital H of t, equal the integral from 9 to t of e of x minus L of x dx for 9 to 23. So now we have a function, defined by the integral here. The value of h of 17 to the nearest whole number is 3,725. Find the value of h prime of 17 and explain the meaning of both h of 17 and h prime of 17 in the context of this part of the problem here. Alright, so let's first find the value of h prime of 17, because that's what it asks for first here, right? Okay, so h of t is defined for us right here, this function. I want to take the derivative of this function, which means I'm taking the derivative of an integral. What fundamental theorem of calculus? Second fundamental theorem of calculus. That's all this is. When you take the derivative of an integral, what happens? It cancels out, and the x gets replaced with the variable there. So it's now e of t minus L of t times the derivative of t, which is just 1. Right, we have to use the chain rule right again. The lower limit disappears, right, because you can imagine plugging the 9 in, but then multiplying by the derivative of 9, which is 0, so the lower limit disappears because when you plug in that 9 and multiply by the derivative of 9, you get 0 for the lower limit. The upper limit stays because t plugs in, and then you multiply by the derivative of t, which is 1. So this is what the derivative ends up being. That's the second fundamental theorem of calculus right there. Boom. Notice it did not say, use the second fundamental theorem of calculus. It gives you the setup and expects you to know that, oh, this is how we're going to do this.
Wait, so where would the 9 go? You would plug it in for t, right?
The 9 and the t technically both get plugged in here, right? But then in each case, you then, by the chain rule, you have to multiply by the derivative of that. Because you're taking the derivative of this thing.
Oh, yeah. And then
Derivative of t is 1, derivative of 9 is 0, so that's why the lower limit disappears.
Where would you plug it in?
In for the x's, just like you did for the t's. It's upper limit plugged in minus lower limit plugged in. But because the lower limit's 9, it just goes to 0. It becomes 0 because you're multiplying by 9. All right, now we want to find h. Is it good? Sorry, I don't want to skip on there. Are you okay with that?
I think so.
I mean, I can show it to you more explicitly here. Let me show you.
Well, then we can just
later
move on.
All right. So then h prime of t is this. So it means h prime of 17 is what? E of 17 minus L of 17. Now here's the benefit of typing this function into y1. You can now go you can go now to your table, right? This is a function, so I can now go to my table and type in 17. Because I want to know what E of 17 is. There it is. 380.49 or 488, we'll say, because I want to use 3 decimal places there. Okay? So 380.488. Already in there for us. That's the benefit of having that rate typed into my y1. I'll go ahead and type the L into my y2. Okay, I'll do the same thing then. Table, and 17 for L is 760.77. Oh, I'm sorry, I should actually scroll. So by the way, folks, these are only 2 decimal places that are shown in our table, but if you arrow over to it and highlight it, it gives you the better value right here. So it's actually 760.769. See how I arrowed over and highlighted there? And now I can do that subtraction. 380.488 minus 760, bless you, 0.769. So negative 380.281. You all doing okay? Question or anything? Good. What would our units be here?
This would be in...
What are our units for E?
That's people per hour.
People per hour, what are the units for L?
People per hour.
So if I take a people per hour and I subtract a people per hour, I'm left with what units? If I have some people per hour and I subtract some people per hour, what are my units? People per hour. I'm still, when I subtract, right? If I have oranges and I subtract oranges, I'm still left with oranges, right? Okay, so people per hour minus people per hour, I'm left with a certain people per hour. So this unit is people per hour.
What does that mean in the context of a problem?
So that's what we're going to get to. That's what we're going to look at here, right?
So like every hour, negative, at this point, every hour.
Say again, sorry? Unless it specifies otherwise, calculus commandment, thou shalt round to 3 decimal places. Okay, unless it specifies otherwise. So for example, A and B, round to the nearest whole number. But for this, thou shalt calculate 3 decimal places. What's that? There's not, I didn't say there's 10 of them. There's only 2 that I can really remember right now.
What's the other one?
Thou shalt calculate in radians. Unless otherwise specified.
Which is never.
Right.
Number
I'm
3, thou shalt
probably in
respect the
degree,
weight.
I am in degree right now.
Anna, question?
I think it's
You did not get these values?
no, I did not.
Oh, when you subtracted them? So you got this number and this number? Okay, so I'd say retype it in there because pretty sure I
Do you have
can-
masking tape by chance?
I'll have to go look, I'm not sure, probably.
I want to put like a tape on the top of my calculator that says degrees.
Oh, gotcha.
I have one on the back, but
Yeah, yeah.
I look at the back.
I got you. All right, so now, here's where it really, I mean, so, okay, this was all pretty good, but now we have to be able to interpret this, which is where it can get really kind of, you know, complicated, potentially. All right? So, we just calculated h prime, which, and again, let's look at what we did. So, we want to explain the meaning of h prime of 17 in the context of the park, in the context of this problem. What did we do to get h prime of 17? We took e of 17, which is the rate of what? People entering the park minus the people leaving the park.
So that means there's enough.
So we have the rate of people entering minus the rate of people leaving, and then we end up with this number. So what is this? This is going to be a rate, right, of what, though? The rate of the population of the park. That's all you need to say. And then, yes, because it's negative, that indicates it's decreasing. That's right. So we can say h prime of 17 equal to, you know, negative 380.281 people per hour, okay, is the rate of change of people in the park at what? At 5 p.m. Very important what Caleb just said there, right? Because that's one little extra detail to this. It's not just any rate of change, because do we expect the rate of change to be the same at every time in the park? The rate of change is probably going to be changing, right? So the rate of change of people in the park at 5 p.m. So again, you can look at this and see, at 5 p.m. we're now kind of like we're losing people. We're the amount of people in the park is decreasing, right? Because it's a negative rate. Okay, right. Sell more popcorn or something. All right.
In a problem like this, would you suggest, I mean, not that I guess it really matters, but what do you think is better, putting it at 17 hours or 5 p.m.?
You could say at time t equals 17 or at 5 p.m. I think either one's sufficient. What I would probably recommend is just go with the t equals 17 because that way there's less interpretation on your part. Like, it's not wrong, but it's less like, because you could make a mistake with, like, you know, doing an hour calculation or something like that. I would hate for you to lose a point for that. All right, so there's h prime of 17. We're not done yet, though. We still have to explain the meaning of h of 17.
Oh, that's easy.
Okay, so h of 17 is 3,725. And what's the meaning of that?
That's how many people are in the park at 5 p.m.
The number of people in the park at 5 p.m. How do we get that? Well, look at what h of t is defined as. It starts at 9, right, which is when the park opens, and it integrates to the t value, whatever t value that is. Okay, in this case, it's going to be 17, so it'll be 9 to 17. It's taking the rate of people entering minus the rate of people leaving, but it's integrating that. So whereas h prime, which was the rate minus, just the straight up rate minus the rate, was the rate of people in the park, this is not the rate of people in the park, this is the number of people we expect to be in the park based on this model. Okay? So h of 17 equal to 3,725 is the number of people, okay, in the park at, and again, time t equals 17 or 5 p.m. I'm going to just change it up and say at time t equals 17. Okay, but either one is okay there. Okay, so again, free response question, this is probably 3 points, I would imagine. 1 point for the correct value of h prime of 17, and then 1 point for the correct evaluation of h of 17 and each of h prime of 17 and h of 17. So 1 point, and then 1 point for the rate. Okay?
I like D.
All right, so letter D says, at what time t for 9 less than or equal to t less than or equal to 23 does the model predict the number of people in the park is a maximum? What? So letter D's like to take these kind of like curves or turns like this sometimes, like the later kind of parts. They can kind of take a turn where you're like, this is like okay, from here to here, like, you know, from A to B, I can see the progression, and then even to C, okay, there's some progression there. But then letter D, it's like a maximum. How do we find the maximum of something using calculus? Take the derivative
You already have it.
of that thing, okay? So the derivative of, we want to find the maximum number of people in the park. We have a function that describes the number of people in the park. It's h. So we want to take the derivative of it. We have the derivative of it. It's right there. This is also not uncommon to ask this weird question, but you already have some of the work done. So we already know that h prime of t is equal to e of t minus L of t. So the derivative is already taken for us. All right. Is that all we have to do, though, to find the maximum, is just take the derivative? What do we do once we take the derivative to find a maximum? We have to find the critical points, right? So we set it equal to what? 0 or when it's undefined. Now, I don't think we're going to have to worry about it being undefined here. So we want to set the thing equal to 0. Okay, so we're going to do e of t minus L of t, and we're going to set it equal to 0. Okay, how are we going to figure out when this thing equals 0?
Use your calculator.
Use your calculator! So wait, let me show you something even crazier. All right, you ready for this? So you could clear out your y1, clear out your y2, and type in, you could do that, and type in this huge function, e of t, minus this huge function, L of t. Or, because they're already in y1 and y2, you can go down to y3, vars, y bars, function y1 minus vars, y bars, function y2. Y3 is y1 minus y2.
Well, or you
Control
could
Z? Yeah.
Could you not just
Sorry.
set L of T from the left side and find out where they intersect? L of T, Z of T?
You could also, yes. So, yes, you could do that as well. What Austin just said is we add L of T over. You could just then see when L of T is equal to E of T. So you could just see when Y1 and Y2 intersect. You could do it that way as well.
I think you're right to do that.
Well, it's up to you. Okay, so I'm going to turn off Y1 and Y2 so I don't get confused, and I'm just going to look at E of T minus L of T here, which is these two. Oops, bless you. Okay, what should I do? I got to zoom out. Yeah, I changed my window. I like to zoom out to start out here, just kind of get a feel for things. So now I can finally see a curve. Okay, that's crazy. All right, maybe I need to zoom out some. Oh, wait. I want to know when it's equal to 0, right? So over here, we're not going to really worry about because that's negative t's, right? We don't care about that one. But I want to see when it equals 0. So I'm going to look. It looks like we're going to equal 0 here. This, by the way, folks, is an asymptote, so we're not going to worry about that one. But this looks like it could equal 0 here. So I'm going to have to adjust my window. I'm going to make my x max be...
Well, you should make your x max 9, or your x min 9, and your x max 23, right?
Oh, that's true. Yes, x min and x max. Yes, 9 and 23. Thank you. You're right. I should do that. Yeah.
So which one is it?
Sorry. So it's not. It is. Sorry. That's not an asymptote. That is the actual function. I apologize. So yeah, you hear what Austin said. He said adjust your window so it goes from 9 to 23 because that's the t values that we're interested in here. Oh, sorry, from 9 to 23.
What are your y mins and maxes?
Mine ended up being negative 40 and 40. Although I don't know if that matters. Yeah. So if we do then the 0 command here and we go, let's see, I'm going too far left it looks like. All right, so if I'm going to the, I'm going to make sure I'm to the left of it so I can see I'm to the left, hit enter, and then I go down to the right, hit enter, and then guess, hit enter. And so we get, there's our time. Okay, that's a 0. Okay, so at time, we only have this one. This is the only critical point we get.
I mean, you can see that from the behavior of the graph as well.
Right, but we can also, so we could also have graphed the function, well, yeah, we could have, yeah, anyway. We can see this here. So there's our critical point. Now, is this critical point a maximum?
Not necessarily.
No. Increase, no.
Not necessarily.
No, it's not. It's a minimum. It's our graph of it.
This is a graph of H prime, right?
Yeah.
H prime is positive to the left
Yeah, sure.
and negative to the right. So let's think about that, right?
That is a
Positive to the left, negative to the right. So is this a maximum? Yeah. Okay. Now, technically here, when it's asking for a maximum, are we asking for the relative maximum or an absolute maximum? When it says just the word maximum, we're thinking it's absolute. So we should technically check our endpoints as well, right? But we know at 9, how many people are in the park? 0. And at 23, there better be 0 people in the park too, because the park's closed, right? So it's like, they should be out, okay? So this is where our maximum time is. Okay, this is where our maximum time is. So, okay, in the park. Luckily, we don't have to worry about, there's no real, you don't have to figure out how many people are in the park, although we could figure out the number of people in the park at that time. But we don't need to. We're done. That's
We
it.
don't need to justify either, right?
And we don't have to justify either. No. So really, you could have just circled the t equals 15.795 hours and then been done. But there it is. Okay. Question, Donovan? Correct. You want to, because anytime you're working with absolute extrema, absolute maximum, absolute minimums, you want to consider those endpoints as well. Endpoints of your interval, which is in this case 9 and 23.